Welcome you all guys to Debugging Doubts. In today's topic, let us study about RS latch using NAND gate. First of all, we'll try to understand one important property of NAND gate. So in the previous video, I shown how the NAND gate works. If you haven't watched my video, then please click the universal gate link here and you can watch it. Now coming to the NAND gate property, if either input value of the NAND gate is 0 or 1, then what happens? Let us try to understand that. We'll consider one of the input as x, okay? X maybe that is 0 or 1. Now, when one of the input of the NAND gate is 0, what does NAND gate do? 0 into x and whole bar. Then 0 into x is 0. Whole bar will come here and this is equal to 1. So output will be 1 itself. Did you observe? When one of the input is 0, then output is surely 1. Whether the value of x is 0 or 1, it does not depend on it. Now suppose you think that one of the input is 1, then what happens? So NAND gate what it does? 1 into x whole bar, that is x bar. The output is x bar. So if it is 0, then it will become 1, and if it is 1, then it will become 0. So now it depends on x. So we'll not consider on this, but we'll only consider that if one of the input is 0, then output is 1 itself. See, the same thing is given here. If one of the input of the NAND gate is 0, then the output is 1 only. This is very important and you will try to remember it because in further coming flip-flop videos, I will use it. Coming to the main topic, RS latch. What is RS latch? So basically, S is set and R is reset. And Q is output. Now think this Q output is something like a bulb, okay? So when I click on the set button, bulb must glow. That is, when set is 1, Q should be 1. And when reset is 1, then bulb must blow off. So Q will be 0. This is how you can try to visualize it. Now we'll fill the truth table, okay? First we'll consider of 0 and 1. I will take this, okay? When R is 0 and S is 1. You have seen here, right? When one of the input is 0, then directly I should write output as 1. This is NAND gate property, which I shown below truth table also. Okay. Now the output 1 will go inside the input of second NAND gate here. So what does this NAND gate do? 1 into 1 whole bar, that is 1 bar, that is 0. Now this will go in the first NAND gate. Now this 0 will be 0 into 0 whole bar is equal to 0 bar is equal to 1. Once again we got output as 1. So the RS latch is balanced now. So this is the final result. I will write Q is 1 and Q bar is 0. This is how we can fill it. Now consider second point. When R is 1 and S is 0. So S is 0, right? So directly I can write output of this NAND gate as 1. Now this one will go as input to the first NAND gate. So what will happen? 1 into 1 whole bar is equal to 1 bar is equal to 0. So output is Q is equal to 0. Now this 0 will go in this NAND gate. 0 into 0 whole bar is equal to 0 bar is equal to 1. Once again we got the value as 1. This is same as the previous value, right? So the latch is balanced. Now I will fill the table, that is Q is 0 and Q bar is 1. Now what happens when R is 1 and S is also 1? Now we'll consider this case. Here we can't consider which NAND gate to consider, right? Because both of the input are 1 and other input we don't know. So we can select any NAND gate. You can select first NAND gate or second NAND gate. It's your choice. I will start by first NAND gate, okay? So the input of this here is, so the Q bar will go here, right? So I'll write Q bar itself. So what will this first NAND gate will do? Q bar into 1 and whole bar. That is equal to Q bar whole bar, that is Q. Now this Q will go to the second NAND gate. What second NAND gate will do? 1 into Q whole bar, that is Q bar is equal to Q bar itself. So this Q bar will once again go here and the same thing is balanced. So your RS latch is once again balanced. I will write the Q bar. That is, you can see Q remains Q itself and Q bar will remains Q bar itself. So the output which it had in the previous is same as the output which I had in the future process. The output is same here. So we'll write same or hold. Okay. Now consider 0 and 0 case. So what happens? Now the main thing is which gate should we consider? If I consider first NAND gate, I can write it as 1, right? So this one will go here, and here it will be 1 into 0 whole bar. That's equal to 0 bar, that's equal to 1 itself. So what is happening here now? Q is equal to Q bar is equal to 1, which is violating the property. That's why we say that this value is invalid. Output is invalid. It flickers. This is the truth table you need to remember. So in exams, you can refer this table. This was all for today. Thank you all for watching. And if you like my videos, please like it, share it and subscribe it. Thank you.